is considered to be the most important part of this chapter. You know why? Because just by knowing what is and how a simple microscope works, how a combined microscope works, how telescope works, you can be assured that some questions will definitely come from here in the board examination. Usually, most probably, a 5-mark question will come from telescope, microscope and all these things. So, if you want to make some people to study for passing, we will say them always study the optical instruments. And obviously, those who are aiming for very high marks, we will always say them study optical instruments well. So, optical instruments is really a very important topic, and once again, you should not study just by mugging up. Understand how it works, what is the logic behind it, and then only things will be clear for you. Otherwise, for the sake of remembering, you will remember. Numerical comes, you will not be able to solve from there, because if you are not knowing the concept well, it can affect how you are getting the marks. Fine. So, let us enter into the subject now, topic now. Give the heading as optical instrument. Give the heading as optical instruments. So, as the name says, optical instrument, obviously any device which helps you to see through it for some reason. For example, sometimes you want to magnify something, sometimes you want to see something more nearer to you, sometimes you want to see something more clearly for you. So, for all these things, we take help of optical instrument. In fact, our eye is also an optical instrument. So, always remember that optical instruments are the devices which enables you to see things around you with more clarity or with more precision. In that only, we are going to we studied about eye in our 10th standard. Human eye was there in 10th standard. I hope you remember that. And in higher classes, that is in 12th, you study about microscopes and telescopes, right? So, we will in this chapter we have 3 things to study: simple microscope, compound microscope and astronomical telescope, reflecting type and refracting type. So, refracting type is there in detail, reflecting type is there just theoretical, Cassegrain telescope and Newtonian telescope, just the theory of that is there. But numerical wise, you have these 3 things: simple, compound and telescope, which is refracting type astronomical telescope. Okay. Before I go into the working of it, the equations of it, the ray diagrams of it, I want to ask you something. So, suppose I am standing here and I am reading something which is kept in front of me. Suppose in front of me there is a wall, I am trying to read something on the wall and it is not visible to me clearly. It is small, not visible to me clearly. If I want to see it clearly, what should I do? Imagine the present scenario. I am standing in front of a wall. On the wall something is written, some calendar is there and some dates are written, something is written, but I am unable to see it clearly because it is far. What should I do to see it clearly? It's a common sense question. Yeah.
Change focus.
Change focus of our eye. How do you change focus of eye, man? You have any?
Sir, you can go near, sir.
Common sense says that only, Kalai. Good, good. Common sense says that we will go near to it, isn't it? If something is not visible to you, you will go near, it will be visible to you. If after going near also not visible to you, then go and meet doctor, because you have some defect in eye. Otherwise, if something you are not able to see, you go near, it becomes visible. Now, my question is, when you went near the object, whether object became big? Did it happen like that? Whether object became big? No, right?
Sir.
The size of object remained same. But same size object, if you are seeing from far, it looks small to you. If you are seeing from near, it looks big to you. Why? What changes? Any idea? When you are viewing an object and you are viewing from a far distance, it looks small to you. And same object, when you are viewing from a near distance, it looks big to you. What is the reason for that? Anybody can tell me? Anybody, what you know, you can say. All of you have studied this chapter in school by now. So, ideally you should know the answer for this. But even if you don't know, give a try. why things becomes bigger for you or more visible for you when you go near to it. Any idea? Definitely not technically, you are not knowing it. That is a very unfortunate thing. Anyhow, let me tell you. Suppose this is the human eye, okay? And in this human eye, we have this thing called as lens of the eye, okay? And there is an object. I hope everybody knows that the image on our eye is formed on retina. Studied from in your small class, right? In your 10th standard, that the place where the image forms in the human eye is the retina. So, image forms at retina. So, if the image forms at retina, if the object is kept, suppose somewhere here, see, this is the image. The same object, if it is brought nearer, you know what happens? Are you able to feel its size increased? The image size became bigger. Are you able to feel what I am trying to say? If the object is kept far from your eye, the angle it subtends on your eye is small, and so the image formed on the retina is also small. When object comes nearer, the angle that it subtends on the eye increases, and so is the size of image. This angle which the object subtends at the eye is called as visual angle. This angle is called as what angle? Visual angle. Without knowing visual angle, you cannot even think about understanding what is optical instrument, whether it is microscope or telescope. The concept of microscope and telescope itself is derived from where? From visual angle concept. And what is visual angle? It is the angle it subtends on the eye. The bigger the visual angle, the bigger the image. The smaller the visual angle, the smaller the image. Now I hope you understand that why when you went near to something or something came nearer to you, it became more clear to you. Because if some object comes near to your eye, it subtends more visual angle, and more bigger visual angle, it means more bigger the image formed on your retina. Is it clear to you? So you can write one just definition of visual angle. Visual angle, it is the angle subtended by the object at the eye. Please write it down somewhere. Visual angle is the angle subtended by the object at the eye. Angle subtended by the object at the eye. Yuvashri, why is your video off? Andrew, you belong to which school, man? Zion?
Velamal.
Velamal. Nedugundram.
Yes, sir.
Okay. If you are feeling sleepy, you can sleep also. I mean, I will take this topic once again on Wednesday's class. So it's not compulsory for you to sit here. If you want to learn, you can learn. I don't want you to miss the class, but not at the cost of simply sitting here. If you are listening, listen properly. Okay. Be attentive in the class. Okay. So I hope it is clear to everybody why an object which is nearer to the human eye is looking bigger to you. It's just because the visual angle it subtends is more compared to when it is far. This is the base for optical instruments working, because whatever optical instruments they are going to talk about is mainly used for magnifying the image only, isn't it? Like microscope. What is the use of microscope? You want to magnify the object's size and it wants to look clear to you, like you are seeing microscopic object. What is the use of compound microscope? You want to further increase the size of the object. So our aim is to make the object look bigger, and for that we will take the help of visual angle. So when I say the word magnification, generally magnification means HI by HO. You remember it in standard? Height of image by height of object. Why 10th? 12th also you studied this. Height of image by height of object. Ratio of height of image to height of object is known as magnification. Am I right? In the case of optical instrument, we will talk about something called as angular magnification. Angular magnification, which we will represent by capital M. And what does it mean? capital M. Capital M is not talked in the terms of height, rather it is talked in terms of visual angle. So, what is magnification? It is beta by alpha. Now, I will tell you what is beta and what is alpha. Magnification in terms of optical instrument is beta by alpha. What is beta and what is alpha? Beta is visual angle subtended by the final image. Subtended by the final image. And alpha is visual angle subtended by the object. In bracket you can write kept at D for microscopes, only for microscopes, not for telescopes. So, the definition of magnification for optical instrument, whether it is simple microscope, compound microscope or telescope, would be ratio of beta and alpha. That is, what is the visual angle subtended by the final image divided by what is the visual angle subtended by the object. Object should be kept at D. What is D, you know? Capital D, what is capital D? Anybody remembers? It is called as least distance of distinct vision, 10th standard. Least distance of distinct vision. What is the value of this for a healthy human eye? What is the value of capital D for a 25 centimeter? Good. Capital D is 25 centimeter for a healthy human eye. That is, human eye can see from 25 centimeter to infinite very clearly. If something is between 0 and 25, it becomes blurred for you, because human vision is not for that. Human vision, if your eye is not having defect, is from 25 centimeter to infinite. So, this 25 centimeter is called as least distance of distinct vision. It means if something is kept at 25 centimeter, it subtends the maximum visual angle and it is the most clear to you. You know this thing? If you want to see something the most clearly by the naked eye, not by using any other medium, then you must keep the object at 25 centimeter. But there is a catch here. You know what? If you keep the object at 25 centimeter, your eye is having the maximum focus. It means it is having ciliary muscles tightened. So, if something is kept at 25 centimeter, even though it is visible very clearly to you, it is not recommended because it may weaken your ciliary muscles. Those who are working on computers, if you ask your known people, parents who are working on computer, they are advised that when you are working on computers, don't work for longer time. Like you can, after working for 20 minutes, see somewhere far, once again see the computer. Then see somewhere far, once again see the computer. Because if you see far, your ciliary muscle gets relaxed. And when you are continuously seeing something very near, your ciliary muscles are very, tightened, strained condition. So, it affects your eye health. And if you are not changing it, your ciliary muscles will become weak, you may get myopia or hypermetropia. Because your capability of eye to focus will change, will reduce. So, though we are getting the best clarity at 25 centimeter, it is not recommended to see the object at 25 centimeter. That's why when we study also, it is always advised that don't keep it too near to your eye. Because if you keep it too near to your eye, your ciliary muscles will be strained. So, they are always saying that keep little far and study. If you keep little far, then your eyes are not maximum strained. Coming back to the concept. So, if this is clear to you, can I go to the next page? Shall I start talking about the instruments now?
Sir, I have a doubt.
Please ask me, Kalejalvan.
Sir, what is final image, sir?
See, when you have any device, whether it is a simple microscope, compound microscope or telescope, it will form images, right? So, in the case of simple microscope, you will have only one image. But when you have compound microscope or telescope, you will have multiple images. So, in that case, the final image, what angle it is subtending, that is only called as beta. Suppose you have one object and two images, then you will be confused which image I should take for beta. That's why I may use the word final image. So final image means the last image found by a lens is called as final image. You will understand when I come to compound microscope, you will understand that.
Okay, sir. Is it like the extent till which it can be magnified?
Not like that. Suppose I am going to have double lens, suppose I am going to have two lenses. Then if the object is kept here, it will form some image here. Once again, the image found by the object will be acting as the object for the second lens. Once again, it will form an image here. This image will be called as final image. Are you able to understand it? So what angle this is subtending is called as beta, and what angle the object is subtending. But where you should keep it? You should keep it at D. So it is theoretical value, not the practical value. So you cannot really bring the object and keep it at D. But theoretically, when the object would have been kept at D, what is the visual angle it would have subtended? That is only called as alpha. Is it clear to you?
Yes, sir.
It will be more clear. It will be more clear when I go into the topic. So give the heading as simple microscope now. I hope all of you have copied from here what you want to write. Is it done? Can I go to the next page? Andrew Ranjan, have you copied this? Joined late.
Yes, sir, almost.
Can I go to the next page?
Yes, sir, I took a screenshot of this.
Okay. I hope everybody is done. I'll go to the next page now. And next page, I am going to talk about simple microscope. Simple microscope. You know what is simple microscope? What is a simple microscope, you know? Where do we use it? Any real life example? Nobody knows, seriously. Simple microscope is just the magnifying glass here. I think all of you would have played by that. All of you would have used it once in life at least. You know what is magnifying glass, isn't it? Magnifying glass, we used to magnify, actually in childhood we will take it for burning paper. So we will use sunlight, we will keep it for a long time on the paper starts burning. I don't know how many of you have tried this. So it will be crazy in childhood when we use simple microscope. Anyhow, so simple microscope is just a convex lens. It is just a convex lens. So basically a convex lens is called as simple microscope. You know very well about convex lens. Convex lens forms an enlarged virtual image if the object is kept between O and F. It also forms enlarged image when the object was kept beyond, that is between F and 2F and at F, but those images are real images, and real images cannot be seen by naked eye. It has to be seen only by a screen. Am I right? So even though convex lens can form magnified image when the object is kept between F and 2F and at F also, those magnified images are real images. And real images to be seen, we should have a screen. So we will prefer the object should be kept between O and F, because when the object is between O and F of a convex lens, then also we get virtual, erect and enlarged image. I hope you know that. Is it known to everybody or you have doubt in it? I hope everybody knows this. So now what I am going to do, in front of this convex lens, I am going to place an object A, B. Okay. This AB, I am making sure it is present between O and F of a convex lens, because only then it will form what kind of image? It is going to form a virtual, erect and enlarged image, isn't it? So what I am going to do, I am going to draw the ray diagram. One ray goes like this, converges and passes through focus. Second ray goes through optical center, goes undeviated. If I extend in the back side, they both are going to meet at a point, and this is the point where the image is formed. So AB, this will become A dash, B dash. Do you agree with me? This ray diagram is clear to you? Very basic 10th level ray diagram. We kept the object between O and F, it got magnified, and obviously it is virtual and erect, because rays are not really intersecting. We are making it to intersect by extending in the back side. So this is a virtual image, as you can clearly see, which is enlarged. Now What is beta? I have told you. Beta is the visual angle subtended by the final image, isn't it? So see here, this is the final image. What angle it is subtending on the lens? Here beta. Do you agree with me? What is beta? Is it clear to you? Beta is the angle subtended by the final image. In this case, there is nothing like first image and second, only one image is there. So this image, what angle it subtends and the lens is called as beta. What is alpha? Alpha is theoretical value. You have to imagine that there is an eye and there is an object kept where? At a distance of d. The same object AB. So it will form an image. This angle will be called as alpha. I hope you are understanding something. What is alpha and what is beta is clear to you. Is it clear to you? Beta is the angle subtended by the final image and alpha is the angle subtended by the object kept at D. I said you, for microscopes we will keep the object at D. Now, we are going to find tan alpha and tan beta. First, what is tan beta here? Tell me. Please guys, what is tan beta? Tell me. Cooperate. So, this is object distance U, this is image distance V. So, what is tan beta? Can you tell me?
AB by OB.
Tan beta is AB by OB. Yes, you can say, no problem in that. So, AB is height of the object. So, height of the object by OB is U. Can I write like this? I hope I can write like this.
Yes, sir.
Tell me, Anshul.
Sir, will U be negative or?
Actually, we are not using sign convention here intentionally. Okay?
Oh, okay.
Okay. What about alpha? In this diagram, if I ask you what is tan alpha, what will be your answer? If I ask you what is tan alpha, what will be your answer? This is again height of object. One second. Yeah, tell me. What is tan alpha, guys? What by what?
Height of object by D.
Yes, HO by D, isn't it? I have said this to you from the day one of ray optics that we are having some assumptions where rays are paraxial. It means it is subtending small angles. We can take tan alpha as alpha or sin alpha. So here instead of tan beta, I can write this as beta also, isn't it? Or instead of tan alpha, I can write as alpha also. So remember, in all the ray diagrams, what we are going to use? We are going to use tan alpha is equal to alpha is equal to sin alpha. Why we can use this? Because angles are very small. This is our assumption in throughout the ray optics. So I got the value of alpha, I got the value of beta. I know what is magnification. Magnification for optical instrument is what by what? Beta by alpha. In the last page only you learned that magnification is beta by alpha. Now what is the beta value? Beta value is HO by U. What is alpha value? HO by D. So can I cut HO and I get the magnification as D by U. Some books they will also write UE, telling this is eyepiece. Basically, since there is no single lens, we cannot say very boldly it is eyepiece or objective. When we have two lenses, the lens near the eye is called as eyepiece, lens near the object is called as objective. But there is only one lens here. The lens is near the object also, lens is near the eye also. So we can call both UE and UO, but some books will write D by UE. So magnification of a simple microscope is D by UE. Copy it up fast, this formula, D by UE. Make it fast, please.
Sir,
Please tell me.
sir, I have a doubt.
Ask
Sir,
me
for
now.
tan beta, isn't it supposed to be A dash B dash by B dash over?
Yes, you can write that. Yes, I understand. Because you will say that this is the final image. You told that angle is subtended by the final image, but here you are taking the angle subtended by the object itself, isn't it? That's what the doubt is. Am I right?
Yes.
See, luckily here, the angle subtended by the final image and the angle subtended by the object are same. Are you able to feel that? So, if somebody is taking hi by v, they are also right, they are not wrong. Then I will get a different expression. Are you getting my point? If you are writing for tan beta hi by v, then also you are right, you are not wrong. But if you are writing ho by u, then also you are not wrong. They are similar triangles, by the way. If you see this triangle and this triangle, they are similar by angle-angle similarity. This is the common angle and this is 90-degree angle, isn't it? I hope you get my point. So, as you are thinking, we may take hi by v also, but need not to take that, because it can be also taken as ho by u. So, this is true, but it is not required here. I hope it is clear to you.
Yes.
Has everybody copied this? Can I proceed further?
Yes, sir.
Andrew, Ranjan, copied?
Yeah, done, sir.
Okay. Not over yet. Now pay attention. After this only main thing is coming. For all the optical instrument, simple, compound and telescope, what we are going to do, we are going to talk about two cases. Again, NCERT, these two cases are not discussed in detail. But if you look at the book back exercise question, there have been questions where they have used these two cases. So, I will teach both cases to you very clearly. Pay attention. In any optical instrument, one scenario is called as maximum magnification. And second scenario is called as normal adjustment. Now, what is the meaning of maximum magnification? See, please pay attention. Before some time I was telling you that if the object is kept at D, we will have the maximum magnification. Am I right? Now, when you are seeing through a lens, image can form at various locations, isn't it? If I change the object position, image position will also change. If the image is forming at 60 centimeter, if the image is forming at 40 centimeter, if the image is forming at 30 centimeter, in which case you will see the image in the maximum clarity or the maximum magnification. Obviously 30 centimeter, because the image is forming near to the value of D. So, if you want maximum magnification, the only condition is image should form at D. Image should form at D. And normal adjustment means image forms at infinite. Image forms at infinite. Now pay attention. Before some time I said you that if image is forming at D, our eyes will be in strained condition. Why is it so? Because that time our ciliary muscles are too much strained. So this condition is also called as strained eye condition. Some books will write this also, strained eye condition. Why? Because the image is forming at D. And this case is also called as relaxed eye condition. It is called as relaxed eye condition. Whatever I am going to write on this board, this only I am going to use for all the three instruments, whether it is simple microscope, compound microscope or telescope. For all the three instruments, I am going to use the same concept. That is, I will find the magnification, and after finding magnification, I will try to find what is the maximum magnification and what is the magnification under normal adjustment. Okay, let us see what is the thing. So, if it is maximum magnification, as I told you, U will be minus UE. I am using sign convention now, but V will become d, in this case minus d. So what is the formula? 1 by f is equal to 1 by v minus 1 by u. So it will be 1 by minus d minus 1 by minus ue. So 1 by f means 1 by fe. 1 by fe will become equal to 1 by ue minus 1 by d. Or I can write 1 by ue became equal to 1 by fe plus 1 by d. Can I write like this? Can I write like this? Just I have rearranged the terms, nothing much I have done. So here I have taken object distance as ue, image distance as d, because I told image should form at d. And then I put in the formula of lens formula, and I got the value of fe. I rearranged the term and I got u. Why I got in terms of ue? Because I have in the formula m is equal to d by ue. Now what I will do, since m is equal to d by ue, I am going to write m is equal to d into 1 by ue. So 1 by ue ke badla I can write 1 by fe plus 1 by d. Can I write like this? Because 1 by ue is 1 by fe plus 1 by d. Now put the d inside, you are going to get magnification as d by fe plus 1. Are you able to understand this? D goes inside, it will become d by fe plus 1. It means the maximum magnification of simple microscope is how much? D by fe plus 1. Same way, if we are going to talk about normal adjustment, also called as minimum magnification or called as relaxed eye condition, here what will happen? U will be minus ue, but v will be minus infinite. So 1 by fe will become equal to 1 by v. V is how much? Infinite, minus 1 by minus ue. So here I will get 1 by ue, this will become 0, is equal to 1 by fe, isn't it? I am going to get 1 by ue as 1 by fe, put in the formula. So I am going to have magnification, and magnification is equal to what by what? D by ue. D by ue means in this case it will be d by fe. So magnification became d by fe. I hope you are getting my point. So magnification of a simple microscope varies between d by fe or d by fe plus 1. If you are understanding properly and if you are listening the class well, you will realize that at the cost of I, you are able to get one extra magnification. It means if your simple microscope is capable of magnifying 7 times, 7x, if you are straining your eyes to get the maximum magnification, it will magnify 8x, not much. Because see, d by fe and here d by fe plus 1, that's all. Just for one extra magnification, you have to strain your eyes. Anyhow, this is just for, just a case, but this is you should remember that. So magnification of a simple microscope under normal adjustment is d by fe, under maximum magnification is d by fe plus 1. If it is clear to you, copy it up fast. If it is clear to you, copy it up fast. Let me know if you are done. Are you done? Can I go to the next topic? What I have written is very important. I am once again repeating it. Can I go to the next page? Anybody has objection, or can I go to the next page? Tell me fast.
Yes, sir.
Done, right?
Yes, sir.
Okay. So now pay attention and let us learn about the the compound microscope. So I am just writing here that magnification of a simple microscope will always be less than equal to 1 plus d by Fe and more than equal to d by Fe. So this is the range in which the magnification of simple microscope varies from d by Fe to 1 plus d by Fe. Is it clear to you? Right. Now give the heading as compound microscope. Now this can trouble you if you fail to understand well. Compound microscope. Regarding compound microscope and telescope, I will teach you the base now, and I will teach you something which is used in almost all the questions, but it may contradict a bit with NCERT exercise book how they have given. So maybe tomorrow or whenever I take the next session, I will even tell you how NCERT says and what is the difference between what I teach today and what NCERT writes in the book. Okay, they have gone a little different way. I have seen the book. Earlier they used to have the same thing that I am teaching, but they changed recently. Instead of using the length of microscope, they are using tube length of microscope. So that derivation also I will do it for you, but first to understand the base, then I will go for how they are doing in the NCERT book. Okay, come on. So in compound microscope, you have two lenses. The smaller one being used as the objective and the bigger one being used as the eyepiece. Now as I said, the meaning of eyepiece is this lens will be near to eye, and meaning of objective is this lens will be near to object. So the lens near to the object is called as objective, the lens near the eye is called as eyepiece. Now there are two lenses here. Why are we using two lenses? To get the better magnification. In the case of simple microscope, we had only one lens. So we got a microscope magnification actually never goes more than 9 times. NCERT says that maximum magnification possible by simple microscope is only 9x. You cannot go beyond 9x. But compound microscope can go 100x also. So you can make 100 times bigger size of the object also by using compound microscope. So in order to increase the magnification, we go for compound microscope. Okay. Now what I am going to do? I have to keep my object. Now pay attention. Here, do I need to once again keep the object between O and F? Not needed. You know why? Because whatever image the objective is going to make is not going to be seen by me directly. I hope you get my point. I am going to see the image only through the eyepiece. It means that even if I am having a real image, that real image will be treated as the virtual object for the eyepiece, and whatever image the eyepiece makes, only that I will be able to see. I hope you are getting what I am trying to say. So, we need not to keep the object between O and F, rather we will keep the object between F and 2F. So, one ray goes like this, passes through the focus of the objective, isn't it? And then second ray goes like this and meets somewhere here. Now pay attention, what I am going to do, wherever it meets, there is the first image formed. This is A dash A to AB, this will become A dash B dash. Are you getting what I am trying to say? And then once again it is going to come and refract, and now if we are going to see from here, this side, then it is going to come like this, and we are going to extend in the back side, and when you meet it, it meets somewhere like this, and this is the point where the final image is formed. A double dash, B double dash. So, from the objective, my first image is forming, and from my eyepiece, my second image is forming, and the second image is the image that is going to be seen by me. I hope you understand what I am trying to say. It is virtual, that's why I am drawing dotted lines. I hope you are able to understand how my this is going to work. What do you call that? Compound microscope is working. Or one more thing, I will draw another diagram which can be little more easy to understand. Let me draw that. One second, give me a second. So, the image formed here. Then I am going to take two rays from the object. One ray I am going to take parallel to principal axis. It is going to converge and pass through focus. Let me remove the eye from here. Yeah. And I will take second ray passing through the optical center undeviated, and then when I extend both, it is going to meet somewhere, and we are going to have the final image A double dash B double dash formed there. If you are wondering why I did that, because I am teaching you in terms of visual angle. So, here only I am able to get the visual angle more clearly, because as per me, the angle subtended by the final image is beta. So, final image is this A dash B dash, A double dash B double dash, which is subtending an angle here, which is beta. Do you agree? And what is alpha? Alpha is theoretical value. I said before some time, you have to keep the eye, just a rough diagram of eye, and keep the object here at which point? At D. So, this is going to be the image, and this is going to be the alpha value, is kept at D, and is going to be HO. Very similar to previous time, tan alpha will become equal to HO by D, which is going to be alpha also. So, alpha we got the value as HO by D, very similar to simple microscope, alpha is HO by D. I have to bother about beta. Before I start talking about beta, draw the ray diagram please. Draw the ray diagram. Everybody, first draw the ray diagram, then I will talk about how I am finding beta. Make it fast please. Let me know if you are done. Proceed further. Have you copied a diagram? See, this diagram you will not find in the NCERT book and all. So, be clear about this diagram. Shall I proceed further? I hope all of you have copied.
Yes, sir.
Okay, please pay attention. So, now tan alpha I have already found, alpha I have found. For finding magnification, I need what by what? Beta by alpha. So, beta is only remaining for me. Okay. So, now if I ask you what is tan beta, what will be your answer? Tan beta is going to be beta. What is the value of beta, tan beta in this triangle? Same way you can write a double dash b double dash by b double dash o, or I can write a dash b dash by o also, isn't it? Do you agree with me? So, a dash b dash by, what is this? It is the object distance for the eyepiece, isn't it? So, I am writing UE. What is this object distance for the objective? What is this image distance for the objective? Do you agree with me? And this is the image distance for the eyepiece. I hope you are agreeing with me about all these terms. UO, VO, UE and VE is clear to you? Where to where what I have taken? Okay. Now, fine. I am having beta value as a dash b dash by UE. To find a dash b dash, I am talking about the magnification of objective. Now, please pay attention. Magnification formula is VO by UO, which is equal to HI by HO, right? Magnification is also written as HI by HO. In this case, HI is what? A dash b dash. HO is what? AB. So, from here can I write a dash b dash is equal to VO by UO into AB. Do you agree with me? Magnification of objective, magnification means V by U, VO by UO. That will become equal to HI by HO. HI for the objective is A dash B dash. HO for objective is AB. So, I hope you are understanding how I got this A dash B dash as UO, sorry, what I wrote here. It is VO by UO into AB, isn't it? Now, I am going to put the A dash B dash here. So, I am going to get beta as what? Beta I am going to get as VO by UO into AB. What is AB? Object HO divided by UE. Is it clear to you? Is it clear to you or not? This beta and this alpha are known to me. So, what will be magnification now? Magnification given by beta by alpha will become equal to, beta is this, VO by UO into HO by UE divided by alpha. Alpha is HO by D. This HO gets cancelled and I get the magnification formula as, I am writing it somewhere here, I am writing, please. Magnification will become equal to VO by UO into D by UE. If you remember the previous derivation, this D by UE is not new for you. already we got d by ue for this magnification, isn't it? Basically, if you see, you will understand that VO by UO is the magnification of objective. D by UE is magnification of eyepiece. So, eyepiece is acting like a simple microscope. I hope you are getting my point. So, can I say magnification of a compound microscope is magnification of objective into magnification of eyepiece? I hope you are understanding what I told now. Something important I told. VO by UO is magnification of objective, we wrote here itself, and D by UE is magnification of the lens, already we have got it. So, I am writing this D by UE is magnification of eyepiece, VO by UO is magnification of objective. So, net magnification of a compound microscope is basically what into what? MO into ME. Is it clear to you? If yes, please copy this up. Whatever equations are there on the board, please copy it up. I will not teach telescope today. After microscope, I will give a pause, and already I have announced the class tomorrow at 2:30 p.m. Those who are free, available and don't have school, for them there is a class tomorrow at 2:30 p.m. where I am going to continue my wave optics, and if time permits, this telescope also I will take. Whatever I am doing is not the final thing. I am going to repeat all these things in the regular class also. It is just being done, not this, whatever I am teaching now, it is just being done because some students are having exam and these topics are there in the school exam. That is why I am taking extra class and finishing for them alone. Don't panic that I will not teach, I will teach these things once again. Let me know if you are done writing. Are you done? Manasa done?
Yes, sir.
So, can I go to the next page? Everybody? Inaya, what about you? Andrew Ranjan? Took the screenshot?
Sir, done, sir.
Done, sir? Okay.
Sir, I wrote it.
Okay, good. If you wrote it, then it is good. So, we came to know that magnification is equal to VO by UO into D by UE. So, we came to know magnification of a compound microscope is VO by UO into D by UE. And once again, like simple microscope, as I said, there are two conditions. One condition is maximum magnification and another condition is normal adjustment, isn't it? So, I am not going to once again derive all these things because as I said to you, it is going to be same for every case. That is, I am going to take U is equal to minus UE, V is equal to minus D, I will derive this and I will conclude 1 by UE is equal to 1 by FE plus 1 by D. So, I am going to use 1 by UE is equal to 1 by FE plus 1 by D. For maximum magnification, 1 by UE is equal to 1 by FE plus 1 by D. How it came, I have already done in the previous page. Same way for normal adjustment, 1 by UE is equal to 1 by FE. Now, magnification for a compound microscope in maximum magnification case will become VO by UO into 1 by D if I have sent inside. So, D into 1 by UE. Actually, 1 by UE, I can write 1 by FE plus 1 by D, so it will become D by Fe plus 1, isn't it? Like I got in the previous case. D by Fe plus 1 is the magnification. That is VO by UO into D by Fe plus 1. This is the magnification of compound microscope for maximum magnification. Same way, here what will happen? Here it will become VO by UO into just D by Fe. This is the magnification under normal adjustment. I hope it is clear to you. So, for maximum magnification, I will take the condition that U will be UE and V will be D. For normal adjustment, U will be UE and V will be infinite, because in that case I am going to have least magnification, but I am going to have relaxed eye condition. Here I am going to have maximum magnification, but I am going to have a strained eye condition. If it is clear to you, just copy it up, and one small thing I will tell you. First you copy it up fast. Hello? 5 minutes I will finish. Is it done? Can I move? Can I further proceed?
Yes, sir.
Okay, now please pay attention. If you see the compound microscope, this is called as length of microscope. That is distance between the objective lens and eyepiece is called as length. Don't confuse between length of microscope and tube length. What is tube length? I will tell in the next class to you. Okay? But now when I am saying length of microscope is distance between the objective and the eyepiece. So what is the distance? If you see in diagram, you will realize length of microscope will be given by VO plus UE, isn't it? So if I want to write what is length of microscope, I will write it here. Length of microscope, compound microscope obviously, will become equal to VO plus UE. I can put mod because you should not take some sign convention. If you add VO and UE, what do you get? Length you get. Moreover, if you see here, you will realize that UE is also equal to FE. 1 by UE is 1 by FE, it means UE is equal to FE. So, since UE is equal to FE, for normal adjustment alone, I can take length as VO plus FE also. Remember that. Generally, the length of compound microscope is VO plus UE. But for normal adjustment, you can also consider it to be VO plus FE. I hope you understand why it is so. Because we can take UE as FE in the case of normal adjustment. Is it clear to you? If it is clear to you, we will take a break here, because most of you are already much sleepy. Some of them have already dropped and slept. So I can take a break here and we can have the class tomorrow at 2:30 once again, where I am going to finish the wave optics, what I was teaching today in the morning, and I may teach the telescope part also if you want to learn. Whatever I am teaching, it is getting recorded also. So don't worry, in case you are missing for some reason and you want urgently to be taught, you can see the recording. Okay? So, have you copied everything? Can I close the class? Anybody is yet to copy anything, or you want to ask something from me? See, we are like on the verge of syllabus finishing in few days or maybe maximum 1 month. So it will be tough time only. Bear with me. Once syllabus is done, there will be the real challenge will start. We will start chiseling you. We will start making you sharp for the board examination by giving many questions, many revisions, many tests. That is the main phase of learning. Teaching is one side. Teaching is happening everywhere. After teaching, how to make you avoid taking mistakes, how to make you reach 65, 69, 68 out of 70. That we will be training you after the syllabus gets over. And now after ray optics and wave optics, nothing remains. Small chapters are only there. So have some cooperation with me. Like this, sometimes if I keep class, attend and learn things. Okay. Bye bye guys. Good night. You can drop if you are done writing. Take care. Bye bye. Yeah.
Thank you, sir.
Good night. Good night. Good night. Good night. Good night.